The farther away a galaxy is, the faster it recedes. This discovery by Edwin Hubble became a cornerstone of both modern cosmology and the Big Bang Theory. So, just how fast is the universe expanding? For decades, scientists have tried to precisely measure this rate of expansion, known as the Hubble constant. There are two main methods used to determine the Hubble constant. One method is analyzing the afterglow of the Big Bang, the cosmic microwave background, and working backward to infer how fast the universe has expanded since then. The other method uses standard candles like Cepheid variable stars and supernovae to measure distances and recession speeds in the nearby universe. The problem is, the two methods yield different values. At first, many assumed the discrepancy came from measurement issues, like telescope errors, interference from dust, or slight miscalculations. But as technology advanced and both telescopes and analysis improved, the two values only diverged more clearly. Does that make any sense? It's like measuring the same person's height as 180 centimeters and 190 centimeters, and then claiming both results are accurate to within 1 centimeter. This inconsistency, now known as the Hubble tension, has led scientists to ask deeper questions. The observations themselves aren't wrong. So what if the missing piece is not in our measurements, but in our very picture of the universe itself? Recently, a research team led by Professor István Szapudi at the University of Hawai proposed a bold hypothesis, one that standard cosmology has long overlooked. What if the entire universe is rotating? Think about it. Almost everything in the universe spins. Planets, stars, galaxies, even galaxy clusters. They're all rotating. So what about the universe itself? The thing that holds everything together. We can't see its full extent with our eyes, nor can we fully picture it in our minds. It's so vast that we may have never dared to apply the concept of rotation to it in the first place. And yet, their claim was that this overwhelming cosmic scale might actually be rotating. According to the team's calculations, a full rotation of the universe would take an astonishing 500 billion years, an unimaginably subtle spin. But remarkably, when this extremely slow rotation is added to existing cosmological models, the Hubble tension neatly decreases. On a rotating Earth, wind doesn't even blow in a straight line, as a result of the Coriolis effect. Everything curves, just slightly. Likewise, if the entire universe is rotating, then the light coming from distant galaxies may have bent ever so slightly along the way, and based on that bent light, we may have built a distorted map of the universe without even realizing it. What makes this hypothesis even more intriguing is that it doesn't conflict with the countless observations that have supported standard cosmology. The large-scale structure of the universe, the spin directions of galaxies, and even the strange patterns in the cosmic microwave background, particularly the so-called axis of evil alignment, can all be naturally explained under the idea of a rotating universe. In fact, the concept of a rotating universe isn't entirely new. Back in 1949, mathematician Kurt Gödel discovered a rotating universe solution within Einstein's general theory of relativity. The problem was, Gödel's model allowed for time loops, closed curves in space-time that could lead back into the past. In other words, it implied time travel and the breakdown of causality, limits that kept it from gaining much traction in the scientific community. But the model proposed by Professor Sapudi's team is different. It simply adds a tiny asymmetry to our existing cosmological model. As a result, it doesn't contradict general relativity. Of course, directly testing this rotation hypothesis is nearly impossible. Trying to observe a universe that spins once every 500 billion years is like trying to film a tornado through a pinhole. But even the smallest, faintest clue could completely reshape the way we see the universe. A universe we once believed was the same in every direction. Maybe, even right now, the universe is rotating like a giant cosmic compass, pointing towards some unknown center we've yet to discover. So take another look at the night sky. Does the universe still look the same to you?